Alright, this is improper integrals, example 8. So, this doesn't have infinity, either top or bottom, and doesn't have an undefined point, either top or bottom. So, what's improper about this one? What's undefined in the middle, right? Or in between the two limits. So, it's still undefined at 0, and 0 occurs between -1 and 2. So, we have to write this as two different limits. So, let's start with the bottom. Okay, so we're going to go limit, and it's going to be b goes to infinity. By the way, it's okay. Ooh, not infinity. 0. Okay. And I'll decide in a minute whether it's from the left or the right. But anyways, b goes to 0. So I'm going to put the b up here. And by the way, you can use whatever letter you want. You don't have to use. Oh, okay. Now I'm kind of rambling. Let me stop rambling and keep working. So that's x to the -3 dx plus the limit as a goes to 0. And I want to go from 2 to a. Right? So basically I'm going -1 to 0, 0 to 2. Now, one thing you cannot do, I said you could choose whatever letters you want, but you don't want these to be the same. Well, I guess technically it could be the same. Right? But don't. Because one thing you don't want to do is confuse the idea that taking the limit over here takes care of taking the limit over here. There are two different limits. That's the most important part. There are two different limits. Okay. So if one of them diverges and the other one doesn't, it doesn't matter. If one of them diverges, the whole thing diverges. All right, as x goes to, oh, sorry, let's continue. Let's integrate first. So if we integrate that, we get, you add 1 to the exponent, divide by exponent, so it's -1/2 x to the -2. Take it from -1 to b. And this is limit as a goes to 0. Oh, so 0, this is coming from the left side, and this is coming from the right side. Right. So again, this is -1/2 x to the -2. Take it from a to 2. All right. So b goes to, I'm just going to put it in. So take the -1/2 out again. So that's going to be b to the -2, or 1 over b squared, minus 1 over 1, so just 1. And here, we'll take the -1/2 out again. So we plug in the 2, it'll be 1/4, minus 1 over a squared. Okay, as b goes to 0, that's going to infinity. Right, it's b squared, so it's positive, no matter what. So that's positive infinity, times negative infinity, so that's negative infinity right there. And then here, that's a minus, and then minus, so that's going to be positive. And as that goes to 0, that's positive infinity. So that's negative infinity. That's positive infinity. So you might think, oh, negative and positive, they cancel each other out. No. Remember, if one of them diverges, it diverges. We just say it diverges. And you can't use L'Hopital's rule. You can't use L'Hopital's rule because these are two different variables. And L'Hopital's rule only applies when you're working with one variable. So you can't use L'Hopital's rule. Like, you might be able to rewrite this if they were using the same variable, but you can't rewrite it to make it fit L'Hopital's rule. Okay? So that's it. It just diverges.